Now we understand the way these molecules are bonded, we can show the next molecule in displayed formula, representing the covalent bonds simply with lines. Here is propane, followed by butane. This alkane series continues and follows the general formula CnH2n plus 2. A general formula allows us to describe a series of molecules that differ from each other by a constant unit. Let us look again at ethane, using the formula CnH2n plus 2, where N represents 2 for the 2 carbon atoms in ethane. We can see that the number of hydrogens will be 2 multiplied by 2 equals 4, plus 2 equals 6, so 6 hydrogens, C2H6. Using this, we can find the molecular formula of other alkanes. For example, decane, an alkane with 10 carbons. Pause the video now and use the general formula to work out the structure of decane. You should have got the answer C10H22, where N equals 10 for the 10 carbons, therefore 10 multiplied by 2 equals 20, plus 2 equals 22, 22 hydrogens. Let us look now at the homologous series of the alkenes. These are unsaturated and so contain a double covalent bond between 2 carbon atoms. Here is ethene. Since there is a double bond, there are now 2 shared pair of electrons between the 2 carbon atoms. Each carbon atom now has only 2 electrons which covalently bond with a total of 4 hydrogen atoms, 2 on each carbon, to complete the ethene molecule. You are only likely to come across alkene molecules with just one double bond, although there can be more within a molecule. The next molecule in the series is propene. As before, there is a double covalent bond between 2 of the carbon atoms, but the other is just a single bond. We now need to fill the molecule with hydrogen atoms to ensure that each carbon has a total of 4 bonds. 2 hydrogen atoms are required at this end of the molecule. This middle carbon already has 3 bonds and so requires just 1 hydrogen, and at this end carbon has only 1 bond and therefore needs 3 more hydrogens. Since we now understand the covalent bonding in these molecules, let us replace the dot-cross diagram with the structural formula. Here is the structural formula of propane. Pause the video now and try and complete this structural formula of butene. Here is the completed structure. Did you get it right? Here are the structural formulas of the first 4 alkenes. Pause the video again and try and complete the general formula. What is the relationship between the number of carbons and the number of hydrogens? Hopefully you got the structure CnH2n. Quite simply, there is double the number of hydrogens than the number of carbons. So, as an example for decane, the molecular formula would be C10H20. Now, at the end of this tutorial, you should have a better understanding of the bonding in the alkanes and alkenes, and how each homologous series follows the pattern given by its general formula.
Alright, and the next video I want you to see is...
You should be able to describe how hydrocarbons can be used as fuels. You should then be able to write balanced equations for the complete combustion of hydrocarbons. In the last video, we looked at how the properties of hydrocarbons... You should be able to describe how hydrocarbons can be used as fuels.
Sorry guys.
You should be able to describe how hydrocarbons can be used as fuels. You should then be able to write balanced equations for the complete combustion of hydrocarbons. In the last video, we looked at how the properties of hydrocarbons depend on the size of the molecule. We saw that short-chain hydrocarbons are highly flammable and they have low boiling points. As the hydrocarbon molecules get larger, they become less flammable and the boiling point increases. Also, longer chain hydrocarbons have a higher viscosity. In other words, they tend to flow more slowly. Now, in this video, we're looking at how hydrocarbons can be used as fuels, and I'm showing you some examples here. Ships, planes, and cars all run on hydrocarbon fuels, and there are lots of other cases where hydrocarbons are used as fuels. Here's the first key fact that you need to learn. Hydrocarbon fuels release energy when they're combusted, and remember that combusted just means burned. During combustion, the carbon and hydrogen atoms in the fuel react with oxygen. In other words, the carbon and hydrogen are oxidized. Now, if the oxygen is unlimited, then this reaction produces carbon dioxide and water, and scientists call this complete combustion. So in this video, we're going to look at how to write chemical equations for complete combustion. I'm showing you here the equation for the complete combustion of methane. As you can see, this equation is not balanced. So how do we balance it? Well, we start by balancing the carbon atoms. We've got one carbon atom in the methane. We also have one carbon atom in the carbon dioxide. This means that the carbon atoms are balanced. Now we need to balance the hydrogen atoms. We've got 4 hydrogen atoms in the methane, but there are only 2 hydrogen atoms in the water. So the hydrogen atoms are not balanced. We need to get 4 hydrogen atoms on the right-hand side. And to do that, we put a large 2 in front of the water like this. Now we have 4 hydrogen atoms and the hydrogen's balanced. Finally, we need to balance the oxygen atoms. On the right-hand side, we've got 2 atoms of oxygen in the carbon dioxide. We've also got 2 atoms of oxygen in the water. So that means that we've got 4 atoms of oxygen in total on the right-hand side. On the left-hand side, we've got 2 atoms of oxygen. So as you can see, the oxygen atoms are not balanced. We need to get 4 oxygen atoms on the left-hand side. And to do that, we place a large 2 in front of the O2 like this. And now the equation is fully balanced. Here's a combustion equation for you to try. Pause the video now and balance this equation. Okay, so we start by balancing the carbon atoms. On the left-hand side, we've got 3 carbon atoms, and on the right-hand side, we've got 1 carbon atom. So we need to get 3 carbon atoms on the right-hand side, and to do that, we place a large 3 in front of the CO2 like this. We now have 3 carbon atoms on the right-hand side, so the carbon atoms are balanced. Next, we need to balance the hydrogen atoms. On the left-hand side, we've got 8 atoms of hydrogen, but on the right-hand side, we've only got 2 atoms of hydrogen. So we need to get 8 hydrogen atoms on the right-hand side, and to do that, we place a large number 4 in front of the water like this. Now we have 8 hydrogen atoms on the right-hand side, and the hydrogens are balanced. Finally, we need to balance the oxygen atoms. On the right-hand side, we have 6 oxygen atoms in the carbon dioxide, and we have 4 oxygen atoms in the water. This gives us a total of 10 oxygen atoms. On the left-hand side, we've got 2 oxygen atoms. So the oxygen atoms are not balanced. We need to get 10 oxygen atoms on the left-hand side. To do that, we need to place a large 5 in front of the oxygen like this. And now the equation's balanced.
All right, so those are the 2 videos that I wanted to show you, right? The next video that I have is a video on alkenes again. All right, but I'm not going to play this one because this one is going to take us over the time, right? So I'm just going to look at 1 or 2 past paper questions because that's what I have in store next. Our second to last or third to last question. 2 homologous series of hydrocarbons are the alkanes and the alkenes. One general characteristics of a homologous series is that the physical properties vary in a predictable way. State 3 other general characteristics of a homologous series. Well, you see this question has been repeating itself, right? You could say they have the same general formula, same molecular formula, consecutive numbers differ by a CH2 group. They have the same functional group. They have similar methods of preparation, similar chemical properties. They behave the same way or similar way in chemical reactions. Next question. How can the molecular formula of a hydrocarbon show whether it is an alkane or alkene, right? Just check the general formula. CnH2n is for alkene and CnH2n plus 2 is for an alkane. Part 3, how does alkanes and alkenes differ in their molecular structure? Well, alkanes, they only have single bonds. There are no double bonds and no multiple bonds, while alkenes, they have at least one carbon-carbon double bond. Right. The next question: natural gas, which is mainly methane gas, is a fossil fuel. What is meant by the term fuel? When we speak of fuel, we are talking about an energy source, a substance, material, compound, element, mixture that is used to produce or release some form of energy. Right. Question: name 2 other fossil fuels. We have coke. You could use coal. You could use petroleum, crude oil, refinery gas, LPG, gasoline, petrol, naphtha. Any of those would be fine. They say name a solid fuel which is not a fossil fuel. You have wood, charcoal, animal dung, animal waste, biomass, uranium, plutonium are all examples of solid fuel which are not fossil fuels. Part B, fossil fuels are formed by the anaerobic decomposition of organic matter. Anaerobic, meaning lacking in oxygen, means the absence of oxygen. The organic matter contains hydrogen and carbon. Suggest the products that would be formed if the decomposition occurred in the presence of oxygen. Right, if decomposition occurred in the presence of oxygen, you'd have the production of water or steam or water vapor, whichever way you want to look at it. Carbon dioxide and carbon monoxide. So they only ask for 2. Yeah, any two of those would be fine. If you put on carbon monoxide, carbon dioxide, or water vapor, any 2 of them would be fine. We say, what are the 2 main disadvantages in the widespread use of fossil fuels? When we use a lot of fossil fuels, they are limited, right? It's a finite resource and it's non-renewable. So when it runs out, that's the end of it. It's depleted, right? It results in the production of greenhouse gases, which affects climate change, which affects global warming, results in the production of acid rain, and the production of poisonous and toxic gases. The next one, butane is an alkane. It has the following structural formula. All right, and they show you the formula. The equation for the complete combustion of butane is given below. All right, they asked you to insert the missing volumes, and the missing volumes was 10 and 65. Now let me show you how I came about with those values. In order, they say 8 molecules of carbon dioxide produce 40 centimeters cube of gas. So what I did, if 8 produces 40, then I found for 1. So 40 divided by 8 gave me 5. So from the equation, if I go back to the equation, there are 13 molecules of oxygen, right? So I multiply 13 by 5, and that gave me 65. And then there are 2 molecules of the butane, right? So I then multiply 5 by 2, and that gave me 10. So I ended up with 65 centimeters cube of oxygen and 10 cm cube of the butane gas. So butane reacts with chlorine to form 2 isomers of chlorobutane, which is a halogenoalkane. What type of reaction is this? That's a substitution reaction because the chlorine would have been replacing the hydrogen. So you could say it's a chlorination reaction, substitution reaction. Photochemical reaction, exothermic reaction, halogenation reaction, free radical substitution. Any of those things would be correct for you to say. And the next thing, explain the term isomer, right? Well, we've said this before, compounds with the same molecular formula, but different structural formulae. All right, the next 1, 2, 3, 4, 5. The next set of slides are all past paper questions, and then it talks about alkenes, but I will stop here for today and will not go any further. So we stop